Okay, so here we have a view of the moon, and as you can see down here, it is the morning of the 14th at about 1:15 in the morning. Okay, so this is the configuration of the sky at that time. You can see south is here at the bottom, southwest is off to the right in this view, and southeast to the left in this view. So it's like we are facing south in a big field. And up here, of course, is the moon. Okay, and we're going to slowly zoom in on that. The light that you see around it is a simulation of our atmosphere and the fact that it does do a little bit of scattering. I'm just going to recenter that moon up for us here as we zoom in. So there's what the moon will look like, roughly speaking, at 1:16 in the morning. And we're going to resume time. So this is real time, and we're not going to sit here and watch this in real time because it will take far too long. But what we will do is we are going to fast forward our way through, and we will watch what happens as time passes. So let's do that. We're going to start accelerating time. There, you see that darkness that's moving over? I'm going to reverse it here. That started around, 2-ish in the morning. I'll roll it backwards a bit. Okay, maybe a little faster. Okay, and you can see it backing off. Let's go forward again. So right pretty much exactly at 2 o'clock, we are going to start seeing what is called the penumbral shadow. So that penumbral shadow looks like that as it comes over. That penumbral shadow is the outer shadow that we've talked about. And that outer shadow is only a part of the picture. Right now, you can see down here in the lower corner the start of the actual shadow of the Earth moving in. We're going to accelerate time a little bit here. And there it is moving in. So that's starting at around a little bit after 10 after 2 in the morning. And we can see here that we are rolling along and the eclipse is beginning to happen. So that is the umbral shadow. That's the darkest part. It's a cone-shaped shadow projecting from the Earth onto the moon. Remember, our configuration is the Earth is between the sun and the moon. Now, our apparent visual brightness has changed there because the moon is actually darkening up a bit. So it's like our eyes are adapting to it. That's all part of this simulator. Okay? And there. Right here at approximately 3:27, almost 3:30 in the morning, we're starting to see the total eclipse. Okay, and that's the effect of it. So you can see that the moon has gained that sort of reddish orange type of hue that is characteristic of this sort of activity, eclipse activity. So we're going to move ahead again. And you can see that it stays pretty much like that for quite a while. Remember, the shadow of the Earth is much bigger than the shadow of the moon on the Earth was during the solar eclipse. That's where the moon was between the sun and the Earth. This time the Earth is between the sun and the moon. So, of course, the solar eclipse only happens during our daytime, and a lunar eclipse can only happen during our nighttime, as viewed from a local location. So we're coming up now on about 4:30 in the morning, and we're starting to see lightning along the edge where it's brightening up. And now you can see our vision is adjusting to this sudden brightness as that main shadow begins to leave. We're going to accelerate this by one step, and you can see the main shadow leaving quickly, and then shortly after, the penumbral shadow. That's that faint shadow that's leaving. And, the moon has set. It's now below ground. So that's basically what's going to happen when we view this eclipse, coming up on March 14th in the early morning.